What can you expect today? This is part one of our PVSol webinars. It's the introduction to the system planning in 2D. So in fact, it's a 2D part in PVSol Premium, or it's, if you only have the PVSol, then you only have the 2D. Then it's also for you, for the PVSol users. What will we show? We will show an on-grid system, or we will plan an on-grid system with net metering and an electric vehicle. During the planning, we show how you can select climate data records, or how you can create your own climate data record. There's a tool which is called MeteoSim, which can be used for that. Then we will define the consumption. We will import a load profile here. There are different ways to determine the number of modules which you can place on a roof. One is the so-called photo plan. For that, you need a digital image and the reference measurement, and then you can find out how many modules have place on your roof. The second option is the so-called roof view. Here you have to, it's an overview of the roof, and here you have to enter the dimensions of the roof. Last but not least, we will also show you the polymorphic configuration and the working with power optimizers. Polymorphic configuration means if you have, for example, two roofs with different orientations and you want to configure them to the same MPP tracker of one inverter. During the webinar, you have also the possibility to ask some questions to us. Please use the chat function for that, which you can find on the right-hand side of your screen. We will try to answer as many questions as possible, but of course, due to the time limit and the number of participants, it will not be possible to answer all the questions. We apologize for that in advance. So that's it for the introduction. So we now have moved into the program, and this is the starting page. So if you open the program, then you are on the welcome page, and here you can load projects, and you also can see that you can find here some tutorials if you're interested in. And what else can we see? There's an icon bar in the upper part here, and this icon bar represents the workflow of the planning. So we go from the left to the right, from the welcome to the presentation. You can change between the different planning steps by clicking on one of the icons, then the tab will change, or you can use the icon arrow icons here on the left-hand side in the bar. But before we start the planning, we will say a few words to the more general settings.
At the beginning, we will have a closer view to the menu bar. Here, for example, under File, you are able to start a new project. You can also open existing project, recent projects. You will find backup copies or example project, and of course, you can save your project and exit the program. Under databases, here you can see how many databases are included, implemented in the software. We have a huge database for PV modules, more than 15,000 module types and more than 5,000 inverters. And of course, there are also additional databases for load profiles, electric vehicles, feed-in tariffs, from grid tariffs, and of course, battery systems and battery inverters. But the reason, because we will have a closer view here, is that you are able to manage favorites, because it's very boring and time consuming if you have to select through the huge database of PV modules, if you would like to select your favorites. And here under Manage Favorites, you are able to create a list of favorites. This is for this type of favorites here. Here are the different favorite groups: batteries, battery systems, inverters, the tariffs, the modules, inverters, and backup generators. And we would like to add one module we are using today to the favorite list. This means we have to select here PV modules, and we have to move on to the company. Of course, we have also select here our favorite. This should be G. Then I have to scroll down, and we have to mark LG Electronics, and then all available modules are listed in the table below, and you only have to check here the box of your favorite, and then it will be add it to a list, and this makes it more easy and comfortable to select your products during the further plan. Yeah, that's it for the databases, and now we come to the options. I would like to start with the user data. Here you are able to enter the company data, the contact data, as well as you can load the company logo, which will appear on the cover sheet of the presentation, as well as in the project summary header. And if we change here on the preview on the left-hand side, upper left-hand side to extend it, here you are able to define the folder where your project should be stored. You can change the unit system from SI unit to US units or SI units with the American wire gauge. And you're also able to change the currency. The currency is based on the settings you have made in the Windows control panel. And here you will find the link to the place where you can change it. Below, this is to have, you can check or uncheck. These are further options. One is the automatic update check once per day at the program start, and the program looks if a new database or a new program release or a new version is available. And your other options here are error messages or hints on the lower part of the window on the lower left-hand side. I think that's it for the beginning, and we should start now with a replanning, and therefore we have to change to the next icon, and these are the project data icon.
Yeah, this is for the more general information of the project. As you can see, we can enter a project number, the project designer, of course, the customer details, customer address and name, and so on. And if the customer address is the same like the address of the PV installation, then you can just adopt it here by using this arrow key, and then it's also in the address of installation field. The first important step of the planning is the setting of the start of operation date. So we select now the end of this month, which means end of October. So
August.
August. Sorry, yeah. I need some holidays, it seems. Okay, then you can enter project name, and if you have a project image available, then you can also select it, and so that's the thing which we will plan now. And all this data here or information also appear later in the presentation report as the cover or front page. Yeah. Okay, so first step is done. We can go to the next window, and this is for selecting the type of installation which we want to plan and to define a climate data record and so on.
Yes, we have mentioned at the beginning, we would like to show you today the planning of a grid-connected PV system with electrical appliances and electric vehicle. There are further systems available. A grid-connected system with electrical appliances, and battery system, then the combination of electric vehicle and battery system, and two further standalone systems with and without backup generator. And I would like to choose this one here, electrical appliances and electric vehicle. Here below, you can switch between the type of design, 3D design or 2D planning. And here we have mentioned that today we would like to show the 2D planning. If you would like to change to the 3D parts, then you have to check the box here. Here below, this is to select the climate data, and you have different options. The easiest and fastest is that you are using these drop-down menus on the left-hand side to select the country, on the right-hand side to select the location. If you would like to open Meteosyn, then you have to click the small globe icon here, and then Meteosyn starts. And within Meteosyn, you are able to select your climate data from a list. This is visualized here. On the upper left-hand part, you have to select the country, and then all available climate data will be visualized in a table. Another option is to select your climate data from a map, from an interactive map. Therefore, an internet connection is required. And here you are able to search for your location via zip code. and we would like to search for the location Delft in the Netherlands. This means we have first to change country to Netherlands. Here we are. And then we have to enter the zip code for Delft, and this is 2611. And yeah, then we have to click the start button, and the location we have searched for is marked in yellow, and the location which are available in a database, these are marked with these red markers. Yeah, and now you have to decide if you would like to select the location or the climate data set closest to your search location Delft, or you're also able to create your own climate data for a new location. And therefore you have to press this button on the lower left-hand side.
So, and if you do so, then a new window is open, which looks pretty similar to the one before. Again, you can enter a country, then we have different search options. You can search for location, again, the zip code, and you can also enter the latitude or longitude. So press start here, we can search for the zip code. And again, a marker appear here in our map. This is now in red, so we click on it, then it changes to green, and our location name is adopted into the field, so we can enter the zip code, or if there's a certain state, and you can also enter the state. Then we have two different options to create our climate data record. One is here, it's already marked, it's called Meteor Norm. This means we would make an interpolation, so that if we create here new records by an interpolation, then we use the Meteor Norm algorithm and also the data which are included in the Meteor Norm database. The second option would be if you have some measured data, so your own measurements, for example, of a whole year, then you could check this one here, and then you would have to enter the data source. So if you have measured yourself, or you got the data from another one, again at the measurement period, and in a small table you can enter the irradiation data. There are different units available just by clicking here on the different rows. If you have also available the outside temperatures, then you could also enter it. If not, then they will automatically interpolate it from existing data. But of course, we don't want to bore you now, so we switch back to the Meteor Norm option. So we interpolate the data from the existing ones, press the OK, and then they will be generated, and they are now here in the database. And if you now press OK, then they are adopted into our planning and can be used for our project.
Yeah, and here we are. Okay, now we have to move on to the next icon, and this icon is called consumption. And here you are able to define your consumption, and again you will have different options. You can use monthly or annual consumption for net metering. This is possible to enter here. This depends on the accounting. If it's monthly or annual, then you can enter here the annual value as well as the monthly value for each month. Another option is that you can define your appliances individually. This means you have to define a group of bulbs, the fridge, as well as a washing machine, and so on and so on. Another option is if you don't have a load profile available, a measured load profile available, you can use one of the standardized profiles. Then the annual consumption is distributed on time according the selected load profile. Here you have to select the load profile which is closest to your normal living. The easiest way you have is if you have a load profile available, a measured load profile from the power company, then you have to select here this option number 1, import load profile.
And that's what we would like to show you. So we have one available, and then this window opens, and well, as you can see, there are also some pre-imported profiles already included. They can also be used. They are, for example, for heat pumps and so on. There are some general profiles from the power companies here. And as I told you, they can also be used. Just click on one, and then you can enter your annual consumption. So if you have a pretty similar consumption profile, yeah, then you can just use it and enter your consumption, your annual consumption, and then it's distributed according to this selected profile. But of course, we want to import a new one, so we click here on import new load profile. Then we can give it a name. You can also enter a command, so where it's coming from, and so on. What we have to do is we have to define several things. One is the time interval, yeah. So with which resolution the profile is measured. In our case, it's 15 minutes. So there are different options available. Then you have to define the number of days. So in fact, if it was a leap year or not. So in our case, let's say 65 days. And those values determine the number of values which you should have in your load profile. So you cannot import the load profile right away. So because there are different formats available from the power companies and so on. So you have to do some work before. So you have to delete all entries, so the header and also the time, etc. You only need one column, and that's the column with the load data. And this column should be in column number 1. Yeah. And then, okay, of course, as you can see, we have 35,040 values. So we need 35,040 rows in our load profile. So that's how it works. So what we have to define is then, of course, the unit of the load profile. So the values are in a specific unit, so kilowatt hours, or whatever is available. And the number format file, which means what is the decimal, if it's a point or a comma. So we have comma. And last but not least, we have, of course, to select our file. Okay. And then we have load values, and if everything was right, then we get the message data import successful. And we have 4,500 kilowatt hours. Yeah. Okay, we press OK. And this is our monthly distribution of our consumption here in this case. So well done. And let's go to the selection of the PV modules and to find out how many modules we can place on our roof.
Yeah, that as we have mentioned at the beginning. Yeah, now it's checked select only from favorites, and then a drop-down menu is limited to the standard module PV Soul as well as our defined favorite here, LG company. Yeah, if we uncheck select only from favorites, then we will have access to all manufacturers and to all module types. And here on the upper right-hand side, here is a database icon, and with this you can open the detailed selection. Then the PV module database is opened, and on the left-hand side you will see all manufacturers, and on the right-hand side these are the corresponding module types. And yeah, also from within the database it's possible to add modules to favorites. Yeah, you can do a right click to one of these existing types, and then you can add these to the favorite list. And it's also possible to create new ones or to copy an existing one and to overwrite the characteristic values. All this is possible. Yeah, we would like to select it here from the favorites. Again, it's limited to our favorite here is our module. Yeah, and we can start to go on with our further planning. And yeah, at the beginning we have mentioned that there are two additional options. One is the planning with PhotoPlan with a digital image and a reference measurement. And the second one is the graphic coverage to determine the maximum number of the roof we can place on a roof. But of course, if it doesn't matter, it is possible to enter a number of PV modules or the PV generator power. This is the easiest way. It doesn't matter. And you know the number of modules, then of course you can enter it. And then you have you only have to define the type of installation. And here you have the choice between roof parallel, roof integrated with and without rear ventilation. And of course, you can also define mounted on a roof and mounted on an open space. And if this is done, you will need to define, of course, the inclination of the roof or of your mounting system and the orientation. And 100-degree corresponds to the south, 90-degree to the east, and 270 to the west. And here in the 2D part, it's also possible to take into account tracker systems. And here are different options. You have a single north, or the single north-south axis. And north-south means the rotating axis, where this is in direction from the north to the south, and the module rotate from the east to the west. Another option would be a single east-west. Then we have a horizontal rotating axis, and the rotation is around this axis from the north to the south. Then we have a further option, single vertical rotating axis, and around this, the module will rotate. And last but not least, the dual axis tracker. And here the module follows the azimuth as well as the elevation of the sun. But in our case, we don't have a tracker system. Okay, now we come to one of these additional options, and we would like to start with Photoplan. We have to check the box here, Photoplan. And afterwards, you have to press the edit button. And now we have to import, to load our digital image. Import picture. And again, here we are. This is our family home. And what you can see here is we have two red arrows. And in the first step, we have to bring these red arrows to the edges of the building. Please hold the left mouse pressed, and then you can drop it here on the left-hand side, the edge of the left-hand side. You can use the mouse wheel to zoom in. And we have to bring these in parallel to this edge here, to the edge of the building. Okay, then we have to place a second arrow, and we can use the corner here in front, or we can use this one here on the right-hand side. Okay, this is also done. Now we come to the second step. Now we have to define the layer in which the module should be placed on a roof. And therefore we have to go here on the upper left-hand side to this icon bar, and we have to press the second icon, add geometry. And then we have to draw a frame or to draw the layer. We have to click each of these corner points here from the roof. And you see here different entry fields, and here you have to enter the dimension. And this is to scale the picture. This is what we have mentioned at the beginning. We need a picture and one reference measurement. This could be the eave length or the distance from the eave to the ridge. And in our case, it should be 10 meters. And if you confirm with the enter button of your keyboard, then this is done, and the inclination, the plane pitch will be automatically calculated from this picture. And in our case, it's around 39 degrees. Last but not least, we have to define the module area here, the solar area. Therefore, you have to click this small wafer. And then again, you can draw the solar area. And again, I have to click the corner points of the roof. And then the solar area will be visualized in blue. This is the area you would like to cover. Here under product choice, you are able to change the border color of the module from white to matte black or matte coal or coal. And you're also able to rotate the modules from a vertical installation to a horizontal installation. And you can also define here the module spacing between the modules in horizontal and vertical direction. And I'll enter here 2 centimeters. After confirming it was OK, the roof will be covered with modules. And to bring it more in the center of the roof, you will find here a center cross cross. Yeah, this is the point where you have started to draw your solar area. There you will find this cross, and you can press these with the left mouse, and then you can drag and drop it more in the middle of the roof. If you shift it a little bit. Okay, if you remember, here on the upper right-hand side, there are two about areas. There was a small skylight as well as a parabolic antenna. And if you click the circle here in the center of the modules, you are able to remove these modules here. And yeah, here we are. And if we press then the after button here, then you will have a preview of the potential PV system on the customer's roof. Yeah, now we can adopt these data. Therefore, we have to close them back. And yeah, here we have to press the adopt button, and then the number of modules as well as the inclination of the roof will be adopted. It will be changed here from 18 to 25 modules and from 30 degree to 39 degree. What you have to define is the orientation. This can't be taken into account or adopted from the image. Yeah. Okay. I have to adopt these, and here we are, 25, 39. Yeah, and these you have to define. Okay, now we can go further. We can move on to the next icon, and this means, yeah, we have to find a suitable inverter. And again, you have, different options. Yeah, one is to ask a program for a suggestion. This means here you have to press this small button, and another option is that you can calculate the configuration. Yeah, here you will get the best configuration, and here you will get all possible configurations. And it makes sense to limit down the number of inverters because we have a huge number of more than 5,000 inverters, and sometimes you will get problems with the RAM. This means it makes sense that you limit down the number of inverters, maybe to one manufacturer, for example. And this is done here with these two icons. It's possible to deselect or to select all matching inverters. The matching ones are visualized here with this green hook, and the non-matching inverters are visualized with this red cross, because maybe their AC power rating is too high or whatever. Okay, and now we have pre-selected this number of inverters, and after confirming with OK and pressing this small button here, then from this pre-selection of SMA inverters, you will get a suggestion. In our case, it's the Sunny Tree Power 7000 TL20. There is an inverter with two MPP trackers, and here you will have two strings. One string with 12 modules in series, and another, the second one, with 13 modules in series. And of course, it's possible to adjust this, to edit this. Here you can have a look what is in a design range and what is outside. As a minimum number of modules in series must be 6, and the maximum number is 22 modules in series. And if you change these, for example, to 5, then you will get immediately information that something is wrong and you have to check the configuration. And on the lower left-hand side, here again is an explanation. The first one is that the total number of modules on a module area is 25 and configured are only 18. And more important is that due to the 5 modules in series, we are outside of the minimum MPP voltage range. And this we can have a look here in the check system. And here on MPP1, you can see that the MPP voltage range is from 150 to 800. And due to our 5 modules in series, we are below of 150. And this means we have losses. And therefore, we have to check. Okay, now I will change it back to 12 and everything is fine. And now I would like to show you the second option, select or calculate configuration. Again, these here are the pre-selected inverters. The number, we have 41 pre-selected inverters. And if I press the start button now, Then we have here all possible configurations, and here in total we have 142 configurations. And the first one, which is calculated here, is the same which the program will suggest you if you select the other options. And then, of course, we have the 7000 TR20. You can use the 8000 and the 9000. And the dimensioning or sizing factor will be changed. And it's also possible, for example, to use two small inverters. As example, the Sunny Boy 3600 TL21. Yeah, I think that's it for the configuration. Now we go further to move on to the electric vehicle.
Well, yeah, and as you can see, it's similar to the selection of the modules and so on. There's a drop-down menu with the manufacturer again. There are different available. So we are in Germany, so we'll select German car here from Mercedes-Benz. And in the left drop-down, there you can find all the different car types which are available from the manufacturer. Then you can see here that you can also enter the number of vehicles. So if you have 2 or 3 or whatever, then you can increase the number and well. So, but we have just one. And what we have to do, we have to define the kilometers or miles, whatever you drive per day. In our case, we drive 50 kilometers per day. And we have to define the times at which we are at the charging station. So just set a hook or remove it. So what else can we see? We have a total mileage per year of 18,250 kilometers, which means we have a consumption here for a car for 3,030 kilowatt hours per year. So together with our 4,500 kilowatt hours from our load profile, we have thanks, Thomas. We have a total consumption of about 7,500 kilowatt hours. Then there is an option here in the charging mode. Here you can select between standard and PV optimized. What does it mean? So if you select standard, then the car battery is fully loaded, and it doesn't matter if you have PV energy available or not. So but if you don't have any PV energy, then it's loaded from the grid. So this is well, if you select standard, then it's the battery is loaded up to its limit. If you select PV optimized, then the car battery is only loaded up to the point where it's enough to drive your next ride. So the desired range per day, for example, the 50 kilometers. So that are the two options. Okay, so that's it for this tab here. So we can change to the next planning step, and this is for the cable losses. So you can enter total loss here as a percentage value if you approximately know how the cable losses are, or you can also enter it in detail by defining the cable length and the cable cross sections.
Here it's separated in AC cables as well as string cables, and there's a difference in calculate and define them. If you define the length for the AC cable from the meter to the inverter, you have to enter the one-way length. And if you calculate or define the length for the string cable, here you have to enter the go and return length. This is the difference between both of these cables. Okay, here we would like to enter 10 meters for the distance from the meter to the inverter. And what you can also do is you can here define the cross section of the cable. We select here 6 millimeters square, and it has a choice between copper and aluminium. And you are also able to calculate here the cross-section for losses smaller than 1%. But if you do this for this cable, then you will get a cross-section of 2.5 millimeters square. And I think it's too small for an AC cable. So we change it back to 6 millimeters square. Yeah, then it's also possible to add a circuit breaker and an FE switch. This will be put here in the cable. And here on a DC cable, here you have to select the MPP tracker. If you remember, we have an inverter with 2 MPP tracker. And for each of these trackers, you have to define the length of the string cable. And in our case, it should be 20 meters with 4 millimeters square and copper. And then we have to change to MPP tracker 2. And again, we have the go and return length of this string cable. And it's also 4 millimeters square and copper. Yeah, and then we can have a look to the maximum total loss. And this is 0.32%. And this is around 24 watt. Yeah, there was entering the cable losses, and now we move on with a circuit diagram, with a plan.
So yes, not much what you can do. So it basically depends on the system which you have planned and the selected inverters, modules, etc. You can add or remove the legend or the drawing space here. And it can be exported into a DXF file. So that's if you want to work with it in a CAD program. So you add something or remove something, then you can do it in a CAD program. Then you would export it to DXF. Then you can save it as a picture, as a bitmap, or you can export it to PDF. And then there are different sizes available from A0 to A4. Okay, so that's it for the plans. We can come to the financing part. So we have to enter the costs of the system, and then we have to define where we get some possible gains.
Yeah, to define the costs, you have to click this edit button here on the upper left-hand side. And on the first page, you have to define the general parameters. This means assessment period, 20 complete years for Germany, and the year of installation. And other countries, of course, you can enter other assessment periods. Then you can also take into account here the annual average return on capital employed. This means that you take into account the decline in value of the money, the inflation. We would like to set this to 0.
It's sometimes a bit confusing.
It's confusing for the customer if you have decreasing.
It's more or less needed if you want to finance your system, and the bank will see it.
And you also have to pay attention here that you make your entries consistent, that all entries are net or all entries are gross. The tax, the pay, I think it's a sales tax. Is not automatically added if you change from net to gross. So you have to do it manually. Okay, now we go further to income and expenditure. This is to define the cost of your system. And you can do it as absolute value, or you can do a specific value, cost per kilowatt peak. And here in our case, I think it's 10,400 euro. So we change here to euro, and here you have to enter 10,400 for the total system. It is also possible, of course, to separate your positions. If you check here detailed entry, then you are able to separate these in inverter, PV, under constructions, cabling, and so on and so on. And here on the lower right-hand side, you can add positions or delete positions, and this can be defined as you want. And then I go back here to income and expenditure. What you also have to define are the outgoing annual operating costs, and this should be 1% of the investment per year. And of course, you can define here further annual consumption costs like a rent for the roof or insurance or whatever, or to clean or to check the system once a year. All this can be entered here. We would like to finance our system with one loan. 3 loans in parallel are possible, and we would like to have a loan capital investment of 100% total financing. And our term should be of the loan should be 10 years. We will have a repayment-free initial period of 2 years. It's an installment loan. The loan interest should be 3%, and you would like to pay back quarterly. Yeah, here under tax, it's possible to take into account tax as well as depreciation, but we would like to recommend to ask a tax consultant. But of course, it is possible. If you check here low for tax, then you have to enter here the tax in percentage, and below you have to define the type of depreciation. It's linear or digressive. Okay, that's it for the general settings, and now we come to our gains.
Yeah, so the costs are defined. So now we have 2 different options here for the concept. There's a surplus feed-in concept or net metering. Surplus feed-in means we produce our PV energy and then we use something for ourselves, and the rest or the surplus is fed into the grid. If you select this one, then you would have to here select, as you can see here, an applied feed-in tariff. Yeah, so there. Well, of course, for Germany, there are some available, and there are also some for other countries. If you don't find yours in the database, then you are able, like we have shown before in the PV module database, to define your own one. Yeah? So maybe you can take a close look into this feed-in tariff here, and then to show how it looks like. And so this one is, of course, now here for Germany, so we will remove it in a short, but this is the general structure here. Yes, you can select the country, then you can type in the type of installation, so the building type or whatever, then the name, and then when it's valued from, so the start date, and how long does it pay, so the payout duration. Yeah, and on the right hand side here, on the upper right hand side, you have to enter the different tariff bands. So in our case, there are different tariff bands, and then that are the prices which you get for every kilowatt hour which you fit into a grid. Okay, so we close that. The other option is if you have kind of a net metering system. So then we change here to net metering. So it means everything which is what you produce from your PV system is fed into the grid, and you can just also get it from the grid as much as you fed in, yeah, or in some cases, of course, some less and so on, and sometimes you are paid if you fed more into the grid than you use, but sometimes it's just loss. Depends on the regulations in your country. So in the Netherlands, we have, for example, a net metering system. So we have already one defined here. So we select that here. Let's take a look on it. Looks pretty similar to the other one. Again, there's from the country, then you can define here the energy supplier, the name. And so if you have to feed in or use a minimum quantity, this could be defined here. Or there's base price, and if you are paid for the surplus, then also if you feed in more than you use, then you could enter it here. It's not the case here in our net metering tariff. And again, here on the upper right part, here you have to enter the energy price. So the price which you are paid for, that's basically that are your savings. So you don't have to pay it to the power company. You can use it yourself, the money, and you for whatever. It's also possible to enter different tariff steps or different prices and so on. Okay, let's close it. And here you can find also a field where you can enter percentage value for an inflation rate for the energy price. In our case, we have set it to 2%. So we have defined our system, and well, now we can simulate and check for the results.
Yeah, and here we are. We are on an overview page of the results on the left-hand side. This is the key numbers of the financial analysis. The revenue or saving per year is around 1,300 euro, and the accrued cash flow, cash balance after the assessment period of 20 years is around 18,600 euro. And if you have a look on the upper right-hand side, you will see the PV generator power we have produced. It's around 7,900 kilowatt hours per year, and the specific annual yield is around 1,050 kilowatt hours per kilowatt peak. Yeah, and below, this is the production forecast, and here is this line. This is a cumulative total energy generation, and as expected, in January and February, we have a higher consumption as production. Yeah, this is the reason because we are below of the zero line here, and yeah, during the year we will have an increasing production due to the summertime. Here we have a higher production as consumption, and at the end of the year again we will have a higher consumption as production, so that in total we will have a surplus here in our case of around 28 kilowatt hours. And here's another graph with the electricity cost saving. Here you can see with PV system we'll have no cost here, and without a PV system you will have costs per month between 100 and 120 euro per month.
Well, yeah, then you can go to the simulation, and there you can see more detailed results. We want to show all of that, and there are different diagrams available. There's a PV system energy balance, which is sometimes interesting. It shows very quick where you have some gains. So basically, it's of course the radiation, and then you have something due to the orientation and inclination of the module surface, but the rest, of course, are losses. So due to the efficiency of the modules, efficiency of the inverters, and so on, so on. Okay, let's go to the financing here. So, well, we have the minimum system operation period of about 10 years. So after 10 years, we go into the plus with our money. And well, yeah, we save per year 1,284 or 85 euro. This can also be shown in the cash flow table for every single year here. So the different savings. And there's also this energy supply account, which shows you for a typical year, the savings or what you produce, what is your consumption, and then the balance of the whole thing. Okay, so what's left? It's the presentation report, of course. So you have the option to export that to the Word or PDF format, or in a Word or PDF file. You configure your presentation, so you can decide what should be in, what should be out, and just by clicking here on the different hooks, remove it or just put it in. Then there's an option to select different other languages compared to the program languages. So the program is available in German, in English, French, Italian, Spanish, Polish, and
Portuguese.
And as you can see, there are different other options here available, like Danish or Chinese, Swedish, Turkish, and so on. Yeah. What else can we here select? So we can select the high resolution of our pictures in the PDF document. Of course, this will increase the size of the PDF document. So it's sometimes, if you have a lot of screenshots and included, then well, can be critical if you want to send it with your mail program. Okay, so I think we should take a look at our presentation. This is the promised start page or front page with all the information which we have defined at the very beginning of our planning, so the customer date and so on. This is an overview of the PV systems, the basic production and the basic results from the financing, and then all the different pages which we have shown in part on a results page, and there's a cash flow table, and last but not least, we have here our photo plan picture with the potential PV system on the roof. Now, this presentation can be printed out, and as I already have told you, you can save it as a PDF or Word file. Okay, so that's one complete planning. So we have promised you different ways of determining the number of modules on the roof. So we have showed you the photo plan planning. So what's left is the graphic coverage. So we have to enter the dimensions of the roof. So we go back to the PV modules. Then we create a new module area. You can copy the existing one, or we could create a new one. So we create a new one now here. Click on this. And then we click on module area 2. Again, we have to select our module here. And now, as you can see here, there's the graphic coverage option. Click on it. And like for the photo plan, we have to edit. And the new window opens. And now we have to enter our dimensions.
Yeah, and this is a default system. And to create your own system, you have to press the small icon on the upper left-hand side, the small trapezium. And then you are able to select from one of the three standard forms, a rectangle, a trapezium, and a triangle. And in our case, we have a triangle. We would like to define the photo plan planning here within the graphic coverage. And therefore, we have to enter the length of the edges here, A and B. And this is 10 meters, and it's around 5.3 meters. And here in the middle, on the left-hand side, you are also able to define border distances. And this can be defined for all borders, the same distance, for example, 0.2. And it's also possible to do it separately. If I uncheck for all borders, then I am able to change, for example, here, the border distance at the ridge, and it sets this to 0. Yeah, after pressing OK, and again pressing OK, and I will be asked if the standard roof should be removed. OK, and here we are. This is one we have defined with 10 meters by 5.3 meters with border distances from 0.2 meters for the gable end west, gable end east, and for the eave. And at the ridge, we have set the border distance to 0. Below of this graph or this image, we can enter the orientation of our roof. Again, 180 corresponds to south, 90 to east, and 270 to west. We would like to set these to 270. And what you also have to define is the roof angle. And if you remember, we had 39 degrees for our roof inclination. Yeah, now we have to move on to define restricted areas, path areas, and therefore we have to mark here in the tree view restricted area, and then again we have to click the small trapezium, and again we will find the three standard forms from the planning before, the definition before, and you will find here an additional option. You can also select a circle if you have a round chimney or a parabolic antenna. And we had two path areas, a small skylight, with the dimensions 0.4 by 0.6 meters, 0.4 times 0.6 meters. And then I have to confirm it's okay. And here our skylight is placed on the point of origin. And the point of origin is the lower left edge. And I can define the position via entering the X and Y coordinates. And this is 7.9 meters in X direction to the right and 3.6 meters in Y directions are here above. Okay, that was our BART area number 1. Now again, I have to mark restricted areas, and then again, click the small triangle here. And now I choose here the circle and have to enter here the radius, and this is 0.2 meters, or should be 0.2 meters. And after confirmation here, again, it's placed on a point on origin, and the right position is 8.5 meters in X and 4.4 meters in Y direction. Yeah, that's it for the restricted areas. And now we have to change to PV area. And again, I have to click the small triangle icon here on the upper left-hand side. And yeah, we have a rectangular standard form, and it would be possible to select again a rectangular form for the PV area. But the easiest way is if you select fit to roof area. Then you don't have to do that much. And yeah, here you are able to define again the installation type. These are the 5 options we already know: roof integrated with and without rear ventilation, roof parallel, and mounted on a roof and mounted open space. And in our case, it's roof parallel. This is the orientation we have defined for our roof, 270-degree. Orientation is to west, and the inclination of our roof is 39-degree. Yeah, now we have to do a right click here within the PV area, and then you are able to cover, or you can edit the PV area before. And yeah, you would be able to define the installation type, again, horizontal or vertical orientation of the modules. And in addition, you are also able to define the column and the row distance. This means the distance in horizontal and vertical directions for the fixing material, for example. If I press now OK, then the roof will be covered with the maximum number of modules. Again, these are 25 modules, and we have in our planning with the PhotoPlan tool. And to bring it more in the center here, you are able to define here the X and Y coordinates for the position of the PV modules. If we enter here 0.45 and 0.2, then it's in the middle of the roof, and it's like our planning we have done before with the other option, PhotoPlan. Yeah, I have to confirm it's okay. And what's left now is configuration of both of these module areas to one MPP tracker. And therefore we have to go further here again to inverters. And here we are, we have module area 2 and module area 1 and module area 2. And what you have to do is you have to press the control key on your keyboard, and with the left mouse key you have to mark module area 2 so that both are colored in light blue. And now this small icon here is activated, configure module areas together, and then these 2 areas will be merged to one. Yeah, now we are able to configure this with an inverter with only one MPP tracker. Yeah.
But it's of course also possible to search for an inverter with 2 MPP or more MPP trackers, and
this
then you
can
configure
also possible, of course,
each side of or each module area to one MPP tracker. But it's not what we want to show now here.
Yeah. And if you would like to configure both to one MPP tracker, then you have to check here polystring or polymorphic configuration. And afterwards, you have to do the configuration manually. This means you have to select via drop-down menu the manufacturer of the inverter, for example, SolarEdge here. Then, of course, you have to select the type. In our case, we use this one here, the 15K, because our total PV generator output is 15 kilowatt peak. Yeah. Then we would like to use power optimizers. Therefore, you have to check here power optimizers, and then you have the choice between SolarEdge and Tigo. But if you have selected as inverter SolarEdge, then of course you have to select SolarEdge optimizer. But if you use an SMA or Fronius inverter, then you can take, for example, Tigo. It would be possible. Yeah, if this is done, we have to select here the type, the type of inverter. You use the P300 optimizer here. And then we have to define the strings we have. We have 2 module areas, one with 25 modules. Yeah, therefore I need 25 optimizers for each module, 1 optimizer. And here on the right-hand side, I have to define the module area. This is module area 1. And then I have to add a second row, again with 25 modules. And this is module area 2 we have. This one is orientated to south, and the second one is orientated to west. Yeah, and here we are. Now it's defined. We will see here a green hook. This means the system is fine. Yeah, and then we can simulate, and everything is done and everything is fine.
So maybe we can also show the option in the inverter configuration, the option that you can make it to 1 string. So it's also important if you have power optimizers, and you can also put all the different strings we have now defined from into 1 string. Then you would have to select here connect string in series. So if you select this option, and then you can see that it changes a bit here at the beginning of the definition for the strings. Well, now we have both substrings merged into 1 string, but as you can see, of course, now it makes no sense. We get a red cross here, because we have exceeded the maximum output here. For which can be handled by the inverter, but in principle it's possible.
But sometimes the minimum number of optimizers per string is 16, and if you have 2 small strings, then it makes sense to combine this in 1 string to reach the minimum number of optimizers.
That's right, and so that's the way how you would do it. Okay, so but we can remove it here to make our planning here the right way. Okay, I think that's it for the webinar. That are the things which we wanted to show you. I would like to thank you for your attention and the time that you invested. Take care.
Yeah, also from my side, of course, thank you for participating in our webinar. And please keep in mind, in 2 days we will show you the 3D part, and maybe we will see you again. Thank you.
Yeah, bye-bye.